Hi, grade 11s out there. We are back and we are having our lesson 2. Lesson 2, we will then move on with the things we started with. All right, so remember we said we are going to use this algorithm plan to look through all the theorems. It's not in order of convention as it is in our textbooks. So we looked at T, triangles, in the first lesson. We looked at X and we looked at D. Today, we would be looking at the letter R. What is the letter R? Now, the letter R would be the letter starting the word radius. And when I talk about a radius, the first thing that comes to your mind is a line from the center of the circle to any part of the circumference. Okay, so quickly, we're going to write a theorem in words. And we're going to show you how to write it when it comes to writing just a short form. All right. Now, the angle subtended. Okay, I'm going to explain what that word subtend means. Forgot to do that in the first lesson. So, all right. The angle subtended by an arc. All right. Either an arc or a chord of a circle. A chord of a circle at the center. Now that's where the radius comes in, because radius would come from the center. Is double. D-O-U. And double means twice, right? I'll just write it there because we'll be using that a lot. All right. The angle it subtends at any point. Watch this, there's a key here that I need us to take note. On the circle. Not just any point, but it must be on the circle. Okay. Now, what do we mean? Quickly, let me explain that to us. The angle subtended, so that I can bring the word subtend also into play. So if I have a circle and I have the center, now, so if I'm looking for the angle, we said either an arc, so let's draw an arc, or a chord rather. All right, if there's no line there, then we can call it an arc, but here we have a chord. Okay, now let's draw a radius. Oh, beautiful. Another radius. Lovely. So that is a radius, that's a radius, and don't forget that this is equal to this. We're going to go somewhere later on with this, and that is a chord there. So the word subtend means produced. The angle produced by an arc or a chord at the center. Where is the angle? This is the angle we're referring to. Okay, angle produced by an arc or a chord. Subtends, okay, is 2 times the angle it subtends or produces at any point on the circle. Wait, what do we mean? We're going to draw this to any point on the circle. Please watch that. Okay, let me start by drawing conventional diagrams and then start changing stuff. Oh, look at that. Oh, let's call this center O. Let's call this triangle A, B, and C. We are saying that the angle at the center, which is what? Angle BOC. Angle BOC is double, is 2 times, that's what we mean by double, 2 times the angle, the circumference, which is BAC. Now, our reason would be written. We don't have to write this whole thing. It will be angle at center is equal to 2 times angle at circumference. So this is acceptable in the exam as a short form for this long theorem. All right, angle at center is 2 times angle at circumference. Please now note, you will be required to prove this. You will be required. Please take note that it must be on the circumference, and it doesn't have to be there. Let me draw different variations. Look, it could be here. It's still coming from the same place, BC. All right, this angle will be the same. So if this is, for example, if this is, let's give this a value. Let's give this a value. If this is theta, this would also be theta. Make sense? All right. While the one at the center becomes what? 2 theta. So it could be anywhere. Look, I could have it that way, but take note, it must be on the circle. That's what the key is. This would also be theta. Already, I am actually looking at one other theorem there, all right, which is our next one. But we are now going to be required to prove this mathematically. Let us prove together quickly, everybody. So here's what the question would look like. Here is what the question would look like. And there are 3 triangles, or 3 types of circles rather. Okay, so I'm going to quickly look at the first one. We have a circle like this, all right? And I have the center of the circle. This is a very conventional diagram that I'm going to draw. Oh no, why am I drawing another circle? A very conventional diagram. We have that. We have that. We have this, all right, and we have that. Let me push this one because of my construction. I have to do a construction, so please listen here. I will be guiding you on how to write your proofs. There we go. Let me get rid of this one. So we're going to have variations of this diagram, but for now, we want to look at the simple, basic one. All right, A, B, and C. Here's the question. Prove that BOC angle is 2BAC. Okay, let's run quickly. That's the question. 4 marks in an exam. If I want to prove, now this is what I will do. Just going to redraw the circle so that we have a very clear picture of my construction. All right, so that's my circle, which I'm given. Check this. I now have my lines drawn. Remember, that is a radius, okay? And we have that there. Now, we have another radius. And we have another line there. And we said this is what? O, this is B, this is C, and this is A. Okay, please watch this, and when you do your proofs, this is exactly what you need to write. I am going to say construction, because we have to construct, and you must tell us what you're constructing. Join AO and extend, you can use any letter, to P. Okay, so let's do that. Now, if I am joining and I'm doing any construction, please do it in dotted lines. Don't do it in bold lines because it wasn't part of the question. Join and extend. Okay, so this will be called my P. All right, so I have done my first construction, join AO. Don't forget, AO is also a radius. Beautiful. Now, for us to be able to identify this, we're going to call this 1 and 2, 1 and 2, just for easy reference. I want to move this line a little bit. Okay, let me take that line out and draw it nicely. I think I missed that point. Yes, beautiful, better. All right, now, here is the proof. Now that I have joined AO and extended it to P, angle A1 is therefore equal to angle B. Why? I don't know if you see a triangle there, and an isosceles. Because AO is a radius, OB is a radius, it means this angle here is actually equal to that angle. In grade 7, we would have said isosceles, but remember lesson 1, it's not called isosceles. It is angles that are opposite equal what? Sides. Angles opposite equal sides. All right, I hope you remember. Let me just put this in bracket. What are the equal sides? AO is equal to OB, and that is radii, so that we can fully have an understanding. Sweet. Now, O1. Let's look at O1. This angle O1 here. Oh, do you notice it's touching my extended line? Our lesson 1. It now becomes an exterior. Oh, therefore it means O1 is equal to angle A1 plus angle B. What's the reason? Exterior angle of a triangle is equal to what? Sum of up interior. Exterior angle of a triangle is equal to sum of opposite what? Interior. But we said A1 is equal to B. Therefore, I can conclude that this is A1 plus A1, which is 2A1, because B is the same as A1. Oh, now if you notice that on the left-hand side of my triangle, I have dealt with this left-hand side. Now, the right-hand side is basically the same. Angle A2 is equal to angle C. Then O2 would be the sum of A2 and C. So we don't need to write all of that. Mathematically, we can just write similarly, O2, angle O2 will be equal to what? Angle 2A2. That's on the right-hand side. Now, let's add. What is O1 plus O2? If we just add, let's see what's going to give us. O1 is 2A1. O2 is 2A2. Something is common. 2. So we have A1 plus A2. And this is what? O1 plus O2. Let's go check O1 plus O2. What O1 plus O2 is. O1. Oh, this is O1 and O2. Oh, that's actually BOC. Oh, beautiful. So angle BOC equals to 2. Let's check A1 and A2. Look at A1 and it's this angle A. Oh, basically it's BAC. And we are done with our proof, my dear learners. That's 5 marks in an exam. Standard, 5 marks. You need to be able to write the proof over and over again. I've got these proofs as little reels on the Crazy Physics YouTube page or the Instagram page. You'd find these little reels, even on TikTok. Yeah, they are there for you to watch over and over. Just a proof. Okay. Now, this is just one of the shapes of the variations. We could actually have the second one, and this is what I'm going to do for the second one. For the second one, it is actually the same. Just giving you a moment to write. Or you can pause the video and then write. Now, the second one is very, very similar. Actually, same proof. The only difference is the shape of this. Okay, let me just clean all of this. Oh no, I didn't. I want the circle. I want the circle. All right, so what is the shape looking like for the second one? The proof is completely the same, and I'll try to help you with understanding that. So here I'll have my radius now extended this way. It's just the position that is different, and I'll be explaining to you why that is. Okay, this is going to be my A, that's my B, and that's my C. Remember, construction, join A, O. This is going to be my O. Let's join A, O. If we join and extend to P, beautiful. Okay, you don't need to write this. You can just draw. Let's use a highlighter to explain quickly. Now that we've joined that, take note of this, that AO is a radius. OB is also a radius. Okay, we call this 1, we call this 2, we call this 1, and we call this 2. This is going to be 2, and that's going to be 1. So if I use a highlighter to quickly guide you through, all right, you have a radius, you have a radius. What does that tell you? Angle A1 is equal to angle B because they form the base of the triangle. Do you see? A1 equals to B. And this is now an exterior. I explained the exterior. The line must be extended. So this is the sum of this and that. A1 plus B, which is, there we go, and that. And similarly, what we said, O2, okay, would be equal to A2 plus C. And the proof remains absolutely the same. Now, this is what I would like to quickly explain to you on why we are using the reflex angle outside. Please watch this. Why we are using the reflex angle outside. So I'm going to do this. Look at point B and C on the left side of the diagram. If I were to extend point B and C, check here, move it up a little bit. Okay, we're moving it up a little bit. What are we going to have? Let's call this B1 and call this C1. Do you see that I have a different shape completely? But it is still what? Angle at the center, because this is what we're focusing on. This angle at the center. Now the angle is here at the center. What if I extend it further? Let me use a different color now. To extend it further, I now have my B there. You see, it's moving up. Move my C there, moving up. So this becomes my B2, and that becomes my C2. If you notice now that joining that and joining that, you would now notice the angle we are looking at is right here. It is the reflex angle here. And the angle we are talking about would be the angle it subtends at that point. I hope that makes sense. That's why we have it like that. The third one is the one that is a bit different in terms of proof, but the theorem remains what? The same. Let me draw the third one quickly. So this one, it's just the diagram. So you could be tested with any of the diagrams. Definitely, in terms of answering questions, you will be tested on all the diagrams. However, on the proof, mostly it's the first one, but you need to know all the three variations. Look at the third one quickly. Look at the third one. So we're still going to have a circle, all right? And we're still going to have the center of the circle. We're still going to have our radius because the angle must be subtended right at the center. But this time around, this angle would right be there. The proof or the theorem is still the same. B, O, C, and then I have my A. So we're still proving that what? BOC, which is at the center, is 2 multiplied by BAC. Just a little tweak in the write-up. That's all. We are still going to join. Let's still join OA and extend to P. So that one remains. That one is going to remain. So that's my P. Now we are going to label the angles. I'll label that one as 1 and label this whole thing as 2. That's where the diagram becomes a bit different. Okay? And I'll do the exact same thing on the side. 1 and 2. Everything is connected to that line that we drew. Okay? So let's quickly write our construction. Join OA and extend. You can use any letter to P. That's P just came to my mind. Awesome. Now, now we have, let's mark all the radius that we have, okay? Let's mark all the radius that we have because we need to understand what is going on. Now, can we then say, let's for easy explanation, I'm going to mark that. Now, do you see, immediately I did that, you should be able to see it clearly. Do you see a triangle here? So angle A1 is still equal to angle B. Makes sense? Angle A1, I thought I was using a highlighter. Angle A1, if you look at that. So radius, also angle A1 is still equal to angle B. So that will not change. Angle A1 equals to angle B. What's your reason? Angles that are opposite equal what? Sides. And which sides are equal? OB is equal to what? OA, radii. Alright, so that's done. Now, we can then conclude that O1 is what? 2A1. Again, what's the reason? Exterior angle is of a triangle is equal to sum of opposite interior angles. Where's my highlighter? So we have that. Remember, we said the line must be a straight line before we can talk about exterior. So that's exterior, which is that. Okay. Now, can we consider the second radius? Now look at this other radius, or this other triangle. Can you see that triangle there? Radius. It therefore means A2 is equal to what? C. And therefore, O2, can you see it's exterior because I am looking at this triangle. O2 is the sum of this. So we're still actually referring to the same thing all along. Similarly, so the write-up is similar, or actually exact same thing here, 2A2. But here is what we are looking for now. We are looking for BOC. This is where the change comes in. Watch this. I am looking for BOC. That small portion. So this time around, we're not adding. It is the big one minus the small one. That would give me BOC. Oh, does that make sense? I'm looking for this. So this entire big area minus the small portion. What would that be? Okay, so O2 minus O1. What is O2, by the way? 2A2. What is O1? 2A1. Okay, this is going to look interesting. Now, what is O2 minus O1? That gives me BOC. 2 into A2 minus A1 if I factorize 2 there. All right, what is A2 minus A1? Let's go check. This is A2, okay, that whole thing. All right, that is A2 minus A1. Also, we are left with just the small part here. And what is the small part? BAC. Oh, makes sense now. BAC. So this is the proof of the third variation that we have. So we have all our three variations in. Angle at the center is 2 times angle at the circumference. Angle at the center is 2 times angle. So you need to know how to do all your write-offs. They are quite similar, only at the last part where we are now subtracting. The first one we were adding. So take a minute, pause the video, go through your notes, write it, and write it again on a fresh page. This is examinable. Examinable. Okay. Let's see if we can answer these questions quickly. We're looking for X and Y. On the first diagram, okay, O is the center of the circle. Okay, so I know that therefore is a diameter. We spoke about this. Oh yeah, so it means this whole thing is 90. Okay, that whole thing is 90, but it's not helping yet. It's not helping. Wait. Now, this is a radius. That is a radius. Oh, guys, don't forget. I should actually remind you of something. When we look at this R, just 1 second. When we look at this R, an additional information that I would love to give you is this. When we look at the letter R, two things that, apart from angle at the center, I had mentioned it in passing, but I want to be very specific in mentioning that, is to remember that we do have a triangle there that is an isosceles. So let's quickly mention that. Okay, so I'm going to draw back my original. But now, if I have this chord, if this is R and this is R, this angle here, let's call it beta, would be equal to this angle here, beta. Why? Angles that are opposite equal sides. Remember, BOC is 2 times. So if this is theta, this would be 2 theta. And we now know that beta plus 2 theta equals to 180 degrees. Sum of angles in a triangle. So that's the second thing there. Apart from angles in a triangle, we look at those 2 angles that are opposite equal sides. All right. Please write this in your note. So every time we talk about radius, we are looking at 2 things. Number 1, we are looking at angle at center, and we are looking at angles opposite. So every time you see this, this will be tested. Angles that are opposite equal sides. Sweet. Okay. All right. So if we come back here, now you would see what I just explained, that this angle is actually x. So already we have the sum of angles in a triangle. All right. So how would we get x? We would say x is what? 180 minus 140. But there are 2 of them there. Divided by what? 2. And we would say sum of angles. Or rather, let's start with this. Sorry, let's start with this. Let's start with this. Angle A is equal to angle OBA. All right. Angles that are opposite equal what? Sides. Therefore, x, which is B, will be what? 180 minus 104 over 2. Sum of angles in a triangle. Now, what is the value of x? 108 minus 180 minus 104 would give us 76. And that will be 38 degrees. And you are done there. But remember, there's still a y that we have to get. How do we get our y? X plus y is actually 90, if you remember our first theorem, lesson 1. So, x plus y equals to what? 90 degrees. What's the reason? Angle in a semicircle. And I told you could also write angles in a semi, and then you put that there. That is also acceptable. Now that I know my x, I can therefore get y. So what will be my y value? What will be my y value? Y will be 90 minus 38, and that will be 52 degrees. Done. Okay, let's look at the next one. Just a few basic examples, but now we are integrating all the other laws into it. So take note, whatever we learn is now part of our arsenal in solving questions. Let's look at this one. We're looking for x and y. Again, quickly. So, I'm going to teach you how to find those angles easily. But one of the things I want you to learn is to name your lines. That's a radius. That's a radius. Oh, that's a radius. I'm already seeing something here. That angle X is equal to angle A2. Let's write everything. Angle A2 is equal to angle X. Angles, opposite, equal sides. Do you see? Radius, radius. And one is 60. That's actually an equilateral triangle. All right, so X would be what? 180 minus 60 over 2. And that would be 60 what? Degrees. What's the reason here? Sum of angles in a triangle. Question is, what is y? Beautiful. Do you notice that DOB is a diameter? Oh yes, DOB. Let me show you. DOB. Like I said, when I'm done, I'll be teaching you skills on solving this Euclidean questions very fast. That's a diameter, which makes angle C 90 degrees. You gotta keep checking. Angle C is 90 degrees. Oh, beautiful. All right, so I'll say angle C equals to what? 90 degrees. Angle in a semicircle. Let's use that. And I know that y plus 90 plus 22 would give me 180. So what is my y? Y therefore would be 90 minus 22. All right, and that would be 68 degrees. With that, sum of angles in a triangle. But do you notice we still have A? A is quite simple. You could use two things to get A. I could simply use angle on a straight line, which is 120, or I notice that this line is extended. Highlighter. This line is extended. So A would be the sum of these two. And I want us to start seeing that. All right? We need to start seeing that exterior because it's going to help us a lot. So we say A equals to 120 degrees. And there are two reasons. Angles on a straight line or exterior angle of triangle is equal to what? Sum of opposite what? Interior. All right, because of my time, I am going to stop here, and I promise in the next lesson we'll move into 2 theorems or 3. All right, just wanted this one to be short because of the 3 proofs. Angle at the center is always 2 times angle at the circumference. And why is r involved? The radius will subtend an angle at the center. The angle, so we cannot talk about the center without referencing the radius. All right, so I needed that to reference the radius. So the angle by the radius is 2 times angle. Please take note, this point must be on the circumference. If I give you this, let me try to draw something here. If I do this, okay, wait just 1 second. If I do this, please take note, this is not at the center, or this is not on the circumference. This, please take note, not theta. Why? It is not on the circumference. Please take note of that. It is not on the circle. If it's not on the circle, that is touching the circumference of the circle, then the theorem would not work. Take note. We're going to see something similar to all of this. So take note, we're talking about the center. All right, so let's go back to that theorem and help me underline. Center and at any point on the circle. Center. And I said, when it comes to radius, we're looking at 2 things, the theorem, and we look at angles that are opposite equal sides. So anytime we see a question that has 2, a radii, radius and radius, It means that we are going to be looking at those two things will be tested. Angle at the center, angles opposite equal sides, and definitely sum of angles in a triangle. I hope this session has been okay. This is going to be our part 2. All right. In part 3, I promise we are going to look at SCP. S, C, and P. And then in the next part will complete, then show you tricks on getting your answers as quickly as possible, and we have fun throughout the whole session. All right. This is lesson 2, done and dusted, and we focused on angle at the center in this case. I'll catch you in the next session. Please make sure you go through, and before you watch the next video, make sure you have the 2, because questions will now be involving everything that we've done up to this point. I'll see you, catch you, and keep well. Goodbye.